So, on the screen right now, you are looking at a practice version of your assessment tomorrow. So your assessment's going to look a lot like this. You will be paired up with someone and you will be solving for a lot of missing angles. On this warm-up, there's not really any instructions, are there? We're just going to solve for every angle that we can, okay? So how this is going to work is I recommend you use a piece of information and then work as many angles as you know, and then use the next piece of information and work as many angles as you know. So I recommend you look at that information at the top and you use it one at a time. Am I going to read all four of those and go mark my picture all at one time? No, because then your markings will get confusing and you won't remember what was congruent and which ones match up. So we're going to start with this one right here. ACB is congruent to EBC. So that's an entire triangle. And we know by CPCTC that if those triangles are congruent, then every piece of ACB matches a corresponding piece of EBC. So the order matters, so I can match them up. Angle A goes with what? Angle E. So if this is 4x, then this is 4x. What else? Angle B goes with angle C because it's listed last and listed last. So there's our 2x and our 2x. What else can we determine from this information? But I think for now, no, we're not going to do that. I think for now, that's all that we can mark given that first piece of information. Okay? So don't assume things you're not allowed to assume. Oh, you went to the next statement already. Okay. So with the first statement, that's all we can mark. We wouldn't be able to solve for x. But you've already moved on to the next statement, which says that segment AC is congruent to segment CB. So I can take away this that I marked. I can revise it. And now I know I'm dealing with two congruent isosceles triangles. So now I can use the isosceles triangle theorem, and now we know that the base angles are congruent. So yes, now we can do 4x plus 4x plus 2x equals 180. Now the great thing is, once we know x cannot represent different values within the same problem. X is x in the same problem. So I can take that 18 and I can plug it in everywhere I see an x. So let's do it. I'm not going to read the next statement up at the top. I'm going to solve for as many angles as I can. So let's start with the base angles. Let's see, 72, 72, 36, 36, 72, 72. All right, so now we have 36, 7 times 18 plus 7, 133, 2 times 18 minus 6, 30. All right, it looks like that's as far as we can go for now. We've got those angles that are given to us because we now know the value of x. Let's keep going. What does the next thing say? It says triangle KJG. Ooh, okay. Triangle KJG is congruent to KCG. Sorry. Whoa. So that figure right there has symmetry. This triangle matches this triangle. They're identical twins. So let's pretend that KG is like a mirror. It's our line of symmetry. They match. So everything on CPCTC tells us everything in KCG is going to match the corresponding part of KJG. Why did I put J and G in the same sentence and C and K? I should have switched those letters up. Okay. So if this one's 30, use your mirror, that one's 30. If this is 133, then this big angle is 133. We can use triangle sum theorem to find the missing angle, 180 minus 133 minus 30. And the triangle sum theorem says 17, 17. Okay, we need to work within that other triangle. We need some more information. How can we work our way into this triangle right here? Let's look at our next piece of information. CH is congruent to FH. CH is congruent to FH, which does not look like it's drawn to scale, but we'll take it, right? We'll take it. CH, FH. Okay. So by the isosceles triangle theorem, the base angles are congruent, 36, 36. Triangle sum theorem says that the vertex angle, are y'all getting 108? 36 plus 36, subtract it from 180, awesome. And then we don't really know on the assessment, are they going to ask us about those angles inside there? They may not. This one by vertical angle theorem would be 108, linear pair would be 72, and we could find that other missing angle. Let's see, 108 plus 17, subtract it from 180. This one right here would be 55. Vertical angles would make that 55. And then we could do 125, 125. We have now found every possible missing angle in the figure. Maybe they would ask for this one right here. You could find that one right there if you needed to. Okay, so this is, like I said, a dress rehearsal for your assessment tomorrow. Hopefully what we did will help you when you're working through it tomorrow. The advice that I gave you to not use all the given at once, to use them one at a time, and the advice that once you find a variable, you can plug that variable in anywhere. All right, so here's the homework answers for drawing conclusions. Page 1 of answers. Okay, so I was asked on number 2 why not to use right angle congruence theorem. So here was the hypothesis. It was if two segments are perpendicular. The conclusion was right angle. So your why, your justification, your why, has to go with your hypothesis in your conclusion. My hypothesis was if perpendicular, then right angle. If perpendicular, then right angle. So my conclusion can't be right angle congruence theorem because I didn't say anything about congruence. I said if two lines are perpendicular, then they form right angles. That's the definition of perpendicular. So your why has to match your assumption, has to match your hypothesis.
Okay.
Thank you. You're asking on number 5, it says, was the given the fact that all the angles are congruent, and then it says that it's an equilateral triangle, and you want to know if the y should be definition of equiangular? Well, if you had said, if your conclusion was ABD is equiangular, then it would be definition of equiangular. But this conclusion that was typed up said ABD is equilateral. All right, so number 5, the given was that all the sides were congruent. You can go in 2 different directions with that. If all sides are congruent, you can state that the triangle is equilateral by the definition of equilateral. But if you wanted to, your conclusion could have been, you would have needed to write it a different way. Your conclusion could be angle 1 is congruent to angle 2 is congruent to angle 3, and then your reason would actually be equilateral triangle theorem. So there's a definition and there's a theorem. Do you want me to go over that a little bit more? I can't remember if I talked about that yesterday. Let me do this really quick. This goes for isosceles and equilateral. So watch the 2 different routes you could take. Okay, you're given this information right here. Let me name the sides real quick. This is what you're given. You could take one route. Conclusion. Angle A is congruent to angle C. Reason. Isosceles triangle theorem. Or you could go this way. Triangle ABC is isosceles. Reason, that's the definition of an isosceles triangle. So those are the directions you could go. You could say that, boom, the angles are congruent, and you're using a theorem to say that. Or you could just state that it's an isosceles triangle. You're just using a definition for that. The same goes for equilateral. If you're going to say the angles are congruent, you're using a theorem. If the sides are congruent, then the angles are congruent. But if you just say it's equilateral, you're using a definition. Okay? I hope that clears it up a little bit. Let's check page 2 of our answers. We're using some CPCTC on page 2. Number 18, real quick, same thing I was just talking about. On number 18, you are given that the angles are congruent. So you could go 2 different ways here. You could state that it's equiangular by definition of equiangular, or you could state that all of the sides are congruent, but that would be the converse of the equilateral triangle theorem. The theorem says if all 3 sides are congruent, then all 3 angles are congruent. If you're going to go backwards and say all 3 angles are congruent, therefore all 3 sides are congruent, you just need to write the word converse before you write equilateral triangle theorem. Okay, if you're going to go backwards. 13 is so important, so let's look at that. Okay, number 13, it says BC bisects ABD. This is ABD right here. If that angle has been bisected, that means it's been divided into 2 congruent angles. So angle 2 is congruent to angle 4. Okay, so that's 13. Those were the correct ones. And then let's look at 17. Given AC is congruent to AB. You're not using this down here at all. You're using the isosceles triangle theorem, which says if 2 sides are congruent, then the opposite angles are congruent. So angle 1 is congruent to angle 2. Yep, so number 17, remember there's 2 routes. If you know 2 sides are congruent, you can either say the triangle is isosceles, or you can say the base angles are congruent. All right, here's the last page of answers, guys. These were easy. These were really straightforward. These were just saying which congruence theorem or using CPCTC. So you weren't really using your sheet for these. So page 3, long homework, really good practice. Okay, today we're going to do some proofs. And believe it or not, I keep telling you that we're taking baby steps, and we're still taking baby steps. We're just really being careful about this. So notice I have a 2-column proof set up. I've already written the statements for you for the first couple times, and then I'll have you write them all by yourself. Don't worry, I am going to let you do that. All right, so for the first 3, I just want you to watch, and I just want to talk through it with you. Super easy ones, just getting your feet wet. All right, number 1. So with proofs, you always have a given, and you have a proof. This is your beginning, and this is your end. Now, when you state the given, you don't have to give a reason. Your reason is just given. You don't have to have a theorem or a definition that backs it up. So when I state angle D is congruent to angle X, I literally just get to write given. That was given to me. I didn't use a theorem. I didn't use a definition. Okay, DF is congruent to XZ. Surprise, surprise. Given. And angle F is congruent to angle Z. So this is as easy as a proof will ever get. That was also given. And so now I state that the triangles were congruent, which was my goal. That was my proof. And my reason would be angle, side, angle. So that is, I can't give you a proof easier than that. So let's take a step up, okay? Yes, you could put theorem if you want. Congruence theorem, very nice. Good, very nice wording. Okay, now let's take a step up and let's do one that's not all just given to us. Okay, given RT bisects QRS. So don't go any further, just write given. Now, if an angle was bisected, then that means I have on my hands two congruent angles. So in step 2 of my proof, I say, hey, angle 1 is congruent to angle 2. QRT, well, that's the wrong one. Oh, this one got bisected. Sorry about that, guys. QRT is congruent to SRT. And now we say the reason. We've been practicing the reasons for 2 days. The reason is definition of angle bisector. Now, if we are trying to prove these triangles guilty of being congruent, we would always add a tick mark to the shared side. Well, what theorem or property are we really using when we add a tick mark to the shared side? We are saying that that side is congruent to itself, and we're allowed to say that because of the reflexive property of equality. Cool. Then we say, here's why the 1 and the 2 were there. Now we can say angle 1 is congruent to angle 2, and that happened to also be given to us. Thank you. And so now we always end with the proof. Don't ever wonder how to end a proof. You always end with the proof. So we're going to end with RTQ is congruent to RTS by angle side angle. Okay, let's watch another one. More blanks this time. Woohoo! Given AE bisects BD. That was given to us. And now we say, hey, what happens after that? AE bisects BD. So BD is the one getting bisected, not AE. That's the one doing the bisecting. BD got cut in half. So I would add tick marks to my picture. What am I really doing when I add tick marks? I'm stating that 2 segments are congruent. BC is congruent to DC. So that's the next thing of our proof. Reason, definition of segment bisector. Now I'm going to state that angle 1 is congruent to angle 2 because I naturally would add arcs to my picture. When you add a symbol, you have to put it in the statement column. So I added a symbol, I have to state it, and now I have to tell the person why. I have to tell the world why I stated it. The vertical angle theorem. I don't know why there's this big space to number 4, but I'll take it. Okay, number 4, always check and see if you've used all your givens. I used this given, but I haven't used this given yet. So I'm going to use it. AC is congruent to EC. What's the reason? Given. I'm going to go mark my picture. And you know how to end this thing. How do we end it? Triangle ABC is congruent to triangle EDC by the side angle side congruence theorem. Woohoo! Okay, your turn. I want you to put this next one in your notes, so get ready. Neil, when would we use CPCTC? We would use that when it says prove angle B is congruent to angle D. Now, on my picture, does B have an arc? Does D have an arc? No. So, after I say that the triangles are congruent, number 6, then I would say angle B is congruent to angle D by corresponding parts of congruent triangles are congruent. So you use CPCTC when you're going past proving the triangle's congruent. When you want to go one step more than that, that's when you use it. Thank you for asking that. Now, a lot of students get confused about proofs. Oh, I need to give you all time to do your quiz. I'm not going to give you the peanut butter and jelly analogy because I don't have time. But the peanut butter and jelly analogy pretty much says that when you're proving, there's no specific order you have to go in. Could Jane's look a little bit different from Anthony's? Sure, as long as you end where you're supposed to end and your statements follow a logical reasoning. Okay? I want you to try this one, and then I'm going to go ahead and work this one because I want you to see it before you need to take your quiz. All right. Given angle 1 is congruent to angle 6, so we can mark our picture and we can write given. Okay. Given angle 3 is congruent to angle 4, We can mark our picture and write given. Okay. Number 3. What do we need to say next? I've used up all my givens. There you go. Yep. So we need to say, I would normally put a tick mark, so I need to say it. If I'm going to add a symbol, I better say it. AC is congruent to AC. Reflexive property. Now what do I say? I'm trying to prove that something that doesn't have tick marks on it is congruent. What do I say next? Before I say that those segments are congruent first, very good. First I better say those triangles are congruent. I can do any order I want. I'll just start with A, B, C just for alphabetical order reasons. A, B, C would match C, D, A if you did that order. The reason is angle side angle congruence theorem. Now I always end with my proof. AD is congruent to CB by corresponding parts of congruent triangles are congruent.